Very good evening, students.
Good evening, sir.
Students, today we are going to start with the new chapter, chapter number 2, that is polynomials from your mathematics textbook. As usual, I'm going to begin with the syllabus for the particular chapter. Beta, all of you observe properly. We will begin with introduction, in which definition and examples for polynomials will be dealt. Later, I'll talk about degree of polynomials. Talk about classification of polynomials in detail. Is that clear?
Yes, sir.
Yeah. Then, beta, depending on this particular aspect, we're going to solve the problems, which is nothing but exercise 2.1. This is the first part of the syllabus for the chapter polynomials. Is that clear to you?
Yes, sir.
Yes, sir.
Afterwards, we're going to deal with the new concept, that is zeros of polynomials. Your 9th standard syllabus for polynomials actually begins from here, beta. The earlier one is nothing but the revision of 7th and 8th standard concept. Is that clear to everyone?
Yes, sir.
Yes, sir.
Once you understood the zeros of polynomial, again you are going to solve some problems, which is nothing but exercise 2.2. Okay.
Okay, sir.
Copy the thing, copy it and take the screenshot also. Quick. Right.
Written, sir.
Okay. Yeah. I'm going to continue the syllabus. But after exercise 2.2, we will continue with the new concept, that is division algorithm for polynomials. What is the meaning and the explanation will be given to you when I'll start with this particular concept. Okay, beta?
Okay, sir.
Then you have to deal with a theorem called as remainder theorem. Then problems based on remainder theorem and division algorithm. That is exercise 2.3. Beta, this is the third part of the syllabus. Is that clear?
Yes, sir.
Then again, a new concept called as factor theorem. And depending on factor theorem, we will solve certain problems, which is nothing but exercise 2.4. Then the last part of the syllabus for this particular chapter, that is algebraic identities. Yeah, algebraic identities. The meaning is you are going to get a list of formulae associated with algebra. Already, beta, in 7th standard, you learned 3. A plus b the whole square, a minus b the whole square, a square minus b square. Am I right?
Yes, sir.
Even in 8th standard also you have studied a few more, the new formulae. This year, beta, all together, right from the beginning, round about 10 to 11 identities, the formulae connected to algebra, you are going to study in this particular chapter. Clear, beta?
Yes, sir.
Yes, sir.
Then again, the problems, nothing but the last exercise for this particular chapter, that is exercise number 2.5. Students, copy fast, quick. Yeah. Beta, Netra, make yourself mute. Students, write down quick. Yeah. Gia, will you read the syllabus written by you? Quick.
Yes, sir. Polynomial
Yeah.
syllabus. Introduction. Definition and examples. Degree of polynomials. Problems. Exercise 2.1. Zeros of polynomials. Problems. Exercise 2.2. Division algorithm for polynomials. Remainder theorem. Problems. Exercise 2.3. Factor theorem. Problem. Exercise 2.4. Algebraic identities. Problem. Exercise 2.5.
Very good, beta. This is the total syllabus for the present chapter, polynomials. Is it understood by everyone, beta?
Yes, sir.
Yes, sir.
So you can assess there are 5 parts in the syllabus, and each part will be having one exercise. Totally, you are going to deal with 5 exercises, right from 2.1 to 2.5. Is that clear, beta?
Yes, sir.
Yes,
Okay.
sir.
With this background, today let us discuss the fundamental aspect, that is the introduction. All of you write down the side heading, beta. Introduction. Yeah. As I said, here we are going to discuss about the definition and the example for the polynomial. Is that clear, beta?
Yes, sir.
Okay.
Yes, sir.
Already you have learned something about polynomial right from 6th standard, beta. You are dealing with. Can anybody tell, according to you, the meaning of polynomial? Quick, beta. Anybody? You can raise the hands in the chat box. What is polynomial according to you people? Whatever answer, beta. What you think that you can tell. Yeah. Anyone?
Yes, sir.
Beta, raise the hands in the chat box. Muskan, tell little bit loudly.
Yes, sir. An expression of more algebraic terms.
Okay. What Muskan is telling is an expression, algebraic expression with more than 3 terms is called as polynomial. Okay, beta. Anybody else? Any other answer? Yeah. Okay. Fine, beta. Let us discuss. First, the sentence given by Muskan. It is but not the 100% definition for polynomial. You have learned in 6th
One
standard.
or
If a polynomial is having 4 terms or more than 4 terms, we call it as a polynomial. See, beta, polynomial having 4 or more terms, again a polynomial. But basically, what is polynomial? That is different, and this polynomial is completely different. Okay. Can anybody else? Pratibha, you were telling something. Yeah, beta.
sir, no, variables, one or more algebraic terms also, sir.
Okay, beta. Fine, no problem. Yeah, anyhow, don't worry, beta. In 6th standard, you had that particular sentence, beta. A polynomial having 4 terms or more than 4 terms is called as a polynomial. Don't worry about that. I will discuss later when I'll come to the classification of the polynomial. What is polynomial? Basically, the main concept is different, that I will discuss now. Okay, beta?
Yes, sir.
Okay, sir.
Okay.
Okay,
Beta,
sir.
all of you observe. Don't write anything. Polynomial. Polynomial are basically the algebraic expressions. What, beta?
Algebraic
Algebraic
expressions.
expression.
Now question comes, what is algebraic expression? You studied in the 6th standard. Algebraic expression is nothing but the combination of variables and numbers. Am I correct, beta?
Yes, sir.
Yes, sir.
Combination of variables and numbers connected together with fundamental operations of arithmetic. What are the fundamental operations of arithmetic, beta?
Addition, subtraction, multiplication, division.
division.
Multiplication, division, multiplication and division. Beta, look at this. Whenever you connect variable with the numbers using certain fundamental operations of arithmetic, it may be addition, subtraction, multiplication and division, you are going to get a mixture that we call it as algebraic expression. Is that clear, beta?
Yes, sir. Yes, sir.
But all the algebraic expressions are not the polynomials. Only few of them, many of them will be the polynomials, and the rest of them are only the algebraic expressions. Is that clear, beta, at present, whatever I said?
Yes, sir.
So in simple words, the combination of variable of the numbers which are connected with fundamental operations of arithmetic will give you the algebraic expressions. In algebraic expressions, you are going to find the polynomials. Is that clear?
Yes, sir.
Now, what is the concept? Beta, the algebraic expressions in which the powers or exponents of all variables are always whole numbers. What, beta? Are always whole numbers. Yeah, such a algebraic expression will be termed as polynomial. Is that clear, beta?
Yes, sir.
Okay, beta, look at this. Whatever I'm showing on the board here, this will give you the complete concept of polynomial. What I said, beta, polynomials are basically the algebraic expressions. These are nothing but the combination of variable and numbers associated with fundamental operations. Maybe addition, maybe subtraction, maybe multiplication, or maybe division. Is that clear?
Yes, sir.
Now,
Yes, sir.
all the algebraic expressions will not be called as polynomials. Selected will be referred, will be termed as polynomials. Which are those? The algebraic expressions wherein the powers or exponents of all the variables, beta, each and every variable, if they are whole numbers compulsorily every time, then only those algebraic expressions will be termed as polynomials. Is that clear, students?
Yes, sir.
Okay, beta, first take down the definition. I will give you the example. Your concept will be much more clear. Okay?
Yes, sir.
Okay, sir.
Write down, beta. Make a para. Already I have written the side heading, introduction, correct?
Yes, sir.
Write down.
Yes, sir.
Make a para. Make a para. An algebraic expression in which the powers or exponents of all variables are always whole numbers is called as what?
Polynomial.
Polynomial. We will take some examples, better. For example, I'll write one simple 2x, which is a very simple polynomial. Then I'll take y to the power 2 minus 17. Then I'll take 3m square plus 14m minus 81. This is one set, beta. Okay. Let us write few more. Minus 18 PQ. Then I'll write 4x square minus 3y. Then let me write one more. 17 p square minus q plus 3r, etc. Better, one more set we will write. 2 by 7 ABC. This is one. Let me write 2x square y, 2x square y plus 3z. This is one. Let me write a very simple 2m plus n minus p. Now write etc. etc. Beta, copy all the three set. Set number 1, set number 2, set number 3. Quick beta.
Yes, sir.
Written.
Yes, sir.
Yes.
Yeah. Students, observe it carefully. We will understand the definition now in deeper aspect. What is that? Beta, the algebraic expression. All are algebraic expressions. The reason, these are the mixture of number and the variable. Numbers and the variables. Numbers and the variables. They are connected with maybe addition, subtraction, multiplication. Even the division is also involved. Got the concept?
Yes, sir.
Yes, sir.
Okay, so first part is clear. These are all algebraic expressions because numbers are combined with the variables with the fundamental operations of arithmetic. Correct, beta?
Yes, sir.
Yes, sir.
Now,
Yes, sir.
concentrate on all the variables, beta. All the variables in every term. Here only one variable is there. Here also one variable. Here it is repeating twice, beta, but only one variable. Am I right?
Yes, sir.
Yes, sir.
You can see there are two variables in the one expression. Here also two variables, x and y. Here also, here three you are going to get, p, q, r. Am I right, beta?
Yes, sir.
Yes, sir.
Then again, three variables, 1, 2, 3 variables, 1, 2, 3 variables. Is that clear, students?
Yes,
Yes,
sir.
sir. Yes, sir.
Now, finally,
Yes, sir.
very important, you have to check the powers or the exponents for the variable. Look at this, beta. What is the power here? Nothing is there means 1. Correct, beta?
Yes,
Yeah.
sir.
Yes,
What is the power? What is the power here for y?
2, sir.
Two, sir.
2.
2. Here it is 2. Nothing is there means 1. Am I right?
Yes, sir.
Yes, sir.
Here 1, 1 beta. Nothing but 1, 1. Okay. Again 2, 1. 2, 1, 1. Am I right? Yeah.
Yes, sir.
1, 1, 1. Here 2 and 1. Here 1. 1, 1, 1. Am I right, beta?
Yes, sir.
Now concentrate on the powers, on the exponents, which I made the n circle. These are all belonging to the set of whole number. Am I right, beta?
Yes, sir.
Yes, sir.
Set of whole numbers. So this will give you the complete meaning of polynomial. So I explain once again the algebraic expressions in which the exponents or powers of all the variables should be whole numbers. Then only we call them as polynomial. Otherwise, they are not the polynomial. They will be called as only the algebraic expressions. Is that clear, students?
Yes, sir.
Yes, sir.
Yeah, beta. Copy fast. Copy fast. Quick.
Repeat, sir.
Written.
Yes,
Yes, sir.
Yeah. Beta, below this, write note, side heading note. If we go for this note, we will understand clearly what are polynomials. Let us see what is that. Note. The algebraic expressions in which powers or exponents of variables are not whole numbers, are not called as polynomials. They will be termed as algebraic expressions only. Algebraic expressions only. I'll give you some examples. I'll give you some examples. Write down quick. Write it fast. Pratibha, can you hear me?
Yes, sir.
Read out, beta, what I have written. Note.
Okay, sir. Note: the algebraic expressions in which powers or exponents of variables are not whole numbers are not called as polynomials. They will be termed as algebraic expression only.
Okay, very good, beta. Now I will give you some examples, beta. Okay.
Yes, sir.
One simple 5x to the power minus 1. Okay, I'll write few more. 2x to the power minus 8 plus 17. Okay, let us go for further. 3y to the power 2 by 3 plus 17z plus 2. This is one more example. Let me take one more example. 2, better, I'll make it minus 2 x to the power root of 5 addition 17, or else make it 173, etc. Write down, but I will explain quick. Write fast.
Yes, sir. Root.
Students, written.
Yes, sir.
Now
Yes,
look at
sir.
the examples keenly. Observe them with attention. You will come to know the exact meaning. Beta, the variable x, what is the power here?
Minus 1, sir.
Yeah, beta. Here, what is the power?
Minus 8.
Yeah. Here, what is the power?
2 by 3, sir.
2 by 3. Beta, here, there is 1. No problem. But 1 is a fraction, 2 by 3. Okay. What about this one, beta? What is the power?
Root 5.
Root of 5. So you can understand, beta, here the powers are not the whole numbers. Am I right? These are not the whole numbers. If you come to this, these are negative integers. Am I right, beta?
Yes, sir.
Or negative.
If you such things will be referred as fractions. Am I right? If you come to this, it is irrational number. Correct?
Yes, sir.
But there is one more possibility, maybe decimals. Decimals and fractions, you will get one or the other same version. So in simple words, if the powers are negative numbers, fractions, irrationals or decimals, then the algebraic expressions will not be called as polynomials. All of you understood the concept beta now?
Yes, sir.
Yes, sir.
This is the actual meaning of polynomials. Any confusions beta?
No, sir.
Sir.
No,
Okay.
sir.
With this beta, I'm going to end the session for today. In the next class, tomorrow, I'll deal with the degree of polynomial and then the classification of polynomials. Actually, beta, this all has been done in your 7th and 8th standard of mathematics syllabus. Am I right?
Yes, sir.
Yes, sir.
But don't worry, I'm going to revise them once again. That is the classification of the polynomials and degree of polynomial. Then we will start with the new concept of 9th standard, that is zeros of polynomial. Is that clear?
Yes, sir.
Okay, beta. I'll be ending the session. Bye. Take care.
Bye, sir.